Another course of CFD fundamentals, we have a project. For me, the project is Unsteady flow through shell and heat and tube type heat exchanger. Today, I will explain how to make a shell and tube type heat exchanger, heat transfer analysis in Ansys software. First of all, we have to know what is shell and tube type heat exchanger. Shell and tube type heat exchanger is a device that transfers heat between two fluids, with one fluid flowing inside a series of tubes and the other flowing outside the tubes within a larger cylindrical shell. In the shell, for my design, for my project, we have considered the shell side, the hot fluid, and the tube side, the cold fluid. I will describe everything in this video. And before that, describing everything, what we will do, I'm just done to tell that in this video we will make a geometry of the cross section of a shell tube type heat exchanger, and then we'll make the flow through this cross section. It will be a 2D geometry, and I'll do the every requirement for the Ansys software, and I'll show that thing accordingly. Now we are opening the Ansys 2025 student version software. In this software, we will use fluid flow. After this, we'll go to the geometry. We will change the analysis type from 3D to 2D. And we will open the design modeler in the geometry. We'll select the XY plan. We'll go to the sketching. Over the settings, we'll mark the grid. Make it 1 meter and 10 the spacing. We'll make a circle. Give the dimension of the circle. 800 millimeter. This is the shell type outer circle, and we will make some other smaller tubes inside the circle, inside this circle. For that reason, we have to select the circle again. We have completed the drawing of tubes inside the large circle by making just copying pasting. Now we will draw the uh, shell side inlet tube. For that reason, we will select the rectangle here, something like that. Now we will trim the extra side. And now we will give the dimension of this tube, of this pipeline of the shell. We'll give it 1 meter. Now we'll go to the modeling section and we'll select the sketch. We see that this is our sketch and we will generate this sketch. We will make surfaces from this sketch. Like now you see that we have generated our geometry. Now we will go for the mesh. For the mesh, we will select the mesh and give it edit. This is our mesh window. One, we will mesh our geometry. For that reason, we will select the method. Before that, we will select the body, whole body, and then apply. And then we will apply the method of triangle method. Now we will select the edges. Now we'll do the edge sizing. We will select the edge. And also we'll do the refinement. We'll give the refinement factor 2. Now we will generate the mesh. It may take some time to generate the mesh. Yeah, okay. Our mesh is okay now. You see that there is a good mesh. Now we will name the we'll make some we'll give the name of the select of some kind of selection. Create name selection. This is the shell inlet. Shell inlet, and this will outlet. Shell wall, and we have to select every small circle to rename it as a tube inlet. Tube inlet, and then okay. Okay. We will open the setup option, and we will click the double precision and solver process for 4. Now we will select the setup conditions, boundary conditions for our project. As this is a we'll select for the transient flow because we have mentioned this unsteady flow, so we have to select this as a transient flow, and before other condition going to other condition, we have to select energy condition on for this project. Okay, so now we will go for now we will select K epsilon 2 equation. Okay, we have to select the material, fluid. We will go for the fluid database From the fluid database, we'll select water, copy, close. Now we will select this is water liquid as our medium of fluid. Now we will select the boundary conditions. First we go for the shell inlet condition. Shell side inlet condition is there. We will select the velocity of water is 15 meter per second and turbulent hydraulic diameter of 0.3. Then temperature is for 405 Kelvin. Then we will apply close. We'll have to select tube inlet condition. Tube set inlet condition, we can give the velocity 5 meter per second and the hydraulic diameter 0.3. And the temperature we can select 288 Kelvin. Now we will select the solution method. Tabular kinetic energy will select second order appoint. Tabular distribution rate will select second order appoint. Now we will select, we will give the monitor residual monitor value, which is 1 10 to the power minus 6. We'll copy paste everywhere. Okay. We will give the solution initialization. We want to compute the solution from shell inlet. Okay. Initialize. Okay. Now for the solution animation, it will be time step solution animation. We will select the contour first. First, we will select the pressure contour. This is pressure control. Okay. Now again, we will go for velocity contour. velocity here. So the contour 2 is a velocity contour. Okay. Now we will select also temperature contour. Contour 3 is a temperature contour. Okay. Now we will set the parameter for the run calculation. We will give number of time steps 400. This is a specified. Okay. Method. We will give the time step size 0.05. Okay. And the maximum iteration or time step we want to give that 30. Now we will give the run calculate command. Now our calculation will be started after some time. You can see that our calculation has been started. It took quite a few time, maybe a couple of hours or more than a couple of hours. So after completion of the solution, we'll come back to the video again. Right now our calculation is completed. We will now check our animations. To check our animations, we have to write our animation uh, video. For that for that for the for to get the animation video, we have to select the video file, and then we will write the contours we have mentioned for contour animations we selected previously. That is pressure contour, velocity contour, and temperature contour. Right now, the animation one is for the pressure control. We will write for the animation video. And after that, we'll make the animation video for other contours also. And it will take some time. So after completion of the animations of video, I will show the everything. I will show the animation video in my video project in this project, and I'll come back again then. Now we have created three animations video for pressure control, velocity control, and temperature control. And now we will check those videos. Okay, for that, I'm just closing this window and then imaging that, and I'll save the project, save as. The project is finished. Now we will check. This is our animation video. This is the pressure control animation video. This is the velocity control animation video. This is the temperature control animation video. It is the graph, temperature, temperature control, velocity control, and pressure control. So here is the end of my videos for this project. Thank you.